Yesterday we talked about classifying systems of equations and solving by graphing. But as you could see in example B yesterday, we didn't exactly have the best example for one that would work with graphing. And so what ended up happening is, while we found that they did intersect, they intersected way off the graph, which means if we had actually used graphing to solve, you wouldn't have a very accurate, or you'd have a huge graph that you'd have to do on a different piece of graph paper. So that's where one of our first of two methods for solving systems, being substitution, comes in handy. So I like to use substitution typically if you have one of your variables that is already either just x or just y. So the first thing that I want to do is solve one of them for x or y. There's not a wrong one in this case to do, because you can really solve whichever one you want, but there's usually a better one. I'm going to go the route of this one, and I always star the one that I solve, and you'll see why coming down the road of these steps, so that way you can understand why mistakes are made. So I'm going to add x to both sides. Well, x plus 0 is x, so that means that y equals x. Then I'm going to box in what needs to be substituted in, and I'm substituting it into the other equation for y, because otherwise your variables aren't going to drop out. That means that when I do that substitution, now I'm going to solve that for the variable. That means now I've got still 2x plus y, which we said is equal to x, equal to 6. Well, 2x plus x is 3x. 3x equals 6, divide by 3, and x equals 2. So now that I've done that, the next step is going to be now to take that and substitute it into the original equation. That is why I went about starring, because now I want to substitute it into the star. And so I'm going to put the blue star here so you remember that that's why I star it, so you can handle it. So then we go ahead and we say, okay, x is 2, so negative of 2 plus y equals 0. So now we solve this, we got to add 2, and we get y equals 2. Now some people are very content to do this and leave it, but first of all, we have to check our solutions. I'm not going to require you to write out your checks, but you're playing roulette if you don't check your solutions. You're saying, maybe it's right, maybe it's wrong. If you turn it in after having checked your solutions, you're going to know that it's right or that it was wrong, and then you can fix it. So the other check, though, is that when we write our solution, you need to write it as an ordered pair. You might want to make sure you make note of that. So that means that my ordered pair is 2, 2. I expect to see it written as an ordered pair. If you give me an answer like this, then I'm going to dock you half a point for not writing it as an ordered pair. The next part today is word problems. And so I've got here Mrs. Maida has a 1% acid solution and a 10% acid solution, but she needs 90 milliliters of a 3% acid solution, so she needs to mix them together because she can't get money from the school to buy it. So how much of each solution does she need? So the first thing you want to do in word problem is look for those keywords. And so I start by looking at how much of each solution. That tells me what my unknowns are going to be. And I also know that she has 1% and she has 10% and she needs to make 90 milliliters of 3%. So then I need to write my two equations. I need to assign my variables too. So I know I need an x and I need a y. Well, what I don't know is how much of each solution. So I'm going to write down that x is going to be the milliliters of 1% solution, and y is going to be the milliliters of 10% solution. So that means that I know that x plus y is going to give me 90. Because if I take milliliters plus milliliters, I'm going to get milliliters. Now the second equation is where I need to factor in for my my percents. So if I take percent of a number, I get real, factor in those percents. So if I take 0.01, which is 1% of x, plus 10%, so 0.1 of y, but I have here percent of a number, I need to have percent of a number. So I have 3% of 90. So you have to have multiples, so we have to have them set together. So then once we have our equations, we're going to solve it using substitution. This is where there is equations that are better. So in our case, this is going to be our better equation to start off by working with. So I'm going to solve, I can solve for x or I can solve for y. I'm used to solving for y, so I'm going to solve for y. So that means that I have y equals 90 minus x, or negative x minus 90, plus 90. I'm going to do 90 minus x only because that I have my minus sign second. Now, I need to substitute this in for y. Putting that in there, I have 0.01x plus 0.1 times y, which is 90 minus x, equals, and I need to take 0.03 times 90. Well, 3 times 9 is 27. So 3 times 90 would be 270, but I need to have that decimal in there, 2 decimal places. So I believe it should be 2.7. Am I correct, Mr. McGree?
Yes.
Okay. So now that I have this, now we can go ahead and I need to distribute. So I'm going to have, I have my 0.01x, and I take 0.1 times 90, which is 9, minus 0.1 times x, which is 0.1x, equals 2.7. Now you're starting to see why a calculator is so darn important. So go ahead and we combine our 0.01x and our minus 0.1x, and I believe I get 0.99x. Am I correct there? Or
Yes.
0.09? 0.09. Sorry, I'm doing this on the fly. Then I'm going to add 9, or sorry, not add 9, add negative 9, or minus 9. And we get negative 0.09x equals what? 2.7 minus 9. Negative 6.3?
2.7
minus 9.
6.3.
Negative 6.3. So then I can divide negative 6.3 by negative 0.09. And I get x equals 70. So then that means 70 milliliters. I'm going to put in labels on the end. So now I take this, and I'm going to put this all the way back into here. So that means that 70 plus y equals 90. See why it's a better one to use from the beginning? Subtract that 70, and I get y equals 20. So how I want you to do this is to go and write your answer as you need 70 milliliters of 1% solution and 20 milliliters of 10% solution. That was a tough one. That's why I did it in the lesson. So what I want you to do now is to go ahead and give these two neutron problems a shot. The first one, you're going to solve the system, straight up system, solve for x and y, give me the order of your answer. And then for D, you're going to set up and solve a system for the sum of two numbers being 18 and one number is twice the other and figuring out what the two numbers are. I do not want you using guess and check. I want you actually using a system of equations because on your test, you will be expected to set up and solve equations or you will not get full points. And as always, make sure you use class meet. And I have it reminding you all to make sure you're writing those summaries.